So more inverse stuff, and again, maybe you guys can help me with this. What's the first step for finding the inverse? By the way, remove all your earbuds, put your cell phones away. What's the first step in finding the inverse? Well, let's write down the function. So basically what we're told is we have this function f of x is equal to 2x cubed plus 1. And we're asked to find the inverse. And they ask us to tell if it's a function or not. We'll circle back to that in a second. Because we can find the inverse operation for sure, but sometimes you can have a function and the inverse is not a function. It's still an equation. Remember, we talked about that way back at the beginning of the year. Do you have a question? Yes? Yeah. So what we do is the first step is we're going to take and replace the f of x with a y, okay? So we're going to plug in y wherever we see a f of x. And I go back and forth on this. I don't know if it should be f of x plug in y, or, but that's what that little symbol means. So that's step 1. Okay. Now what do we do? Raise your hand if you know. What's the next step? Yes? Yeah, we're going to solve for x, which means when I'm done solving for x, it should be x equals some stuff. So, first step, subtract 1 from both sides. So we're just going to do what we normally do, right? That leaves me with y minus 1 equals 2x cubed. Now, we follow order of operations in backwards order, right? So it's PEMDAS, please excuse my dear Aunt Sally. So normally you would do the parentheses first, then you would do exponents, then you would do multiplication, division. But when we're solving an equation, we go backwards. Notice that we subtracted first. That's the very last thing you do in PEMDAS, right? That's the S in PEMDAS. So we're working backwards. In other words, I got to get rid of this 2 first because 2 is multiplying. To get rid of it, I divide. Now 2 divided by 2 is just 1, so on the right-hand side, I've got x cubed, and on the left-hand side, I've just got y minus 1 divided by 2. How do I get rid of that 3, the third power? Well, not square. You guys are used to calling it a square root, but technically what root is it? Cube root, right? It's the third root. Oh, that's not a good one. And so what happens is that the cube root undoes the cube, and over here, I'm just left with x. But remember, whatever I do on one side of the equal sign, I have to do to the other. So my whole thing is the cube root of y minus 1 all over 2. All right, we got x equals some stuff, right? That's step number 2. Okay. What's the next step? Anybody remember step number 3? Yeah. What's that? Oh, yeah. Swap x and y. So wherever there's an x, we're going to plug in a y. Wherever there's a y, we're going to plug in an x. Now what I'm going to do is I'm going to do this first. I skipped this step yesterday, but I want you to see that you could just change the side. Now I like to have, because in the next step when I swap it, and I'm just going to go, when I swap it, see how I have an x here? I'm going to make that a y. And then that equals the cube root. See how I have a y here? I'm going to make that an x. Okay. I like having the y on the left-hand side of the equal sign. That's how it is in your calculator when we go to graph it. It's just easier that way. And you could do that as long as you do it properly. All right. That was step number 3, wasn't it? What's the last step? I think you guys know it, but you don't know how to say it, right? Wherever there's a y, what I liked is as I was watching you guys, and this made me happy, and this is something that you guys don't do all the time, is I saw a lot of people flipping over their notebooks and looking at the steps. I think you didn't know how to say that, right? Because I keep saying it's pronounced F inverse. It's not really F to the negative 1 power. It's pronounced F inverse. So you could just say, we plug in F inverse notation wherever there's a y. So the last step, we do this. Now, does anybody have an idea why we switch that to F inverse? Oh, wait a second. We might not do this last step. Why is that? What does F inverse imply? That the inverse is also a function, but it asks us to determine if the inverse is a function. So maybe we hold off on this. But let's make sure that the equation we have, and you guys understand the difference between an equation and a function? An equation, we have lots of equations, and the equations are simple. The left-hand side of the equal sign equals the right-hand side of the equal sign. We generally, in an Algebra 2 class, have y on one side and x on the other side. So there's a relationship between two numbers, x and y. We don't know what they are. Sometimes they give them to us. Sometimes we solve for them. But that relationship is equal, okay, based on the equation. Now, some equations have I'll say it, and it's very confusing. For each unique input, it only has one output. In other words, if I plug in the number 2, will I get 3 or 4 outputs for y? That's what we have to think about. If we get 3 or 4 outputs for y, or a better way to say it is, no wait, I'm saying that wrong. In other words, we have no repeating x's. In other words, if I plug in 4 into this equation, right, and it'll give me a y value, can I plug in 4 to this equation and get a different value? That's what we're really doing. So before we do this last step of function notation, let's graph these two and see what we get, okay? Now, I think what I'm going to do today, I think I'm going to do this on Desmos, because remember on the SAT you could use Desmos. I like it when you use the fancy calculators too, but I want to show you both. And when you go to college, they probably are not going to let you use Desmos as much. So I want to show you both. So I'm going to put in the first one, the first equation, which was, I got a bunch of calculators going on here, 2x cubed plus 1. So when I plug this in Desmos, I'm going to say 2x cubed, was it plus 1? Is that right? Okay. And then I got to put the cube root. So I got to, I wonder if I do cube root. Oh man, that's a tough one. Root. I'm hoping that I could plug that in somehow. Yeah. So I don't know if you guys are aware of this. See this little thing here? To get to, it's kind of like, oh, I got to move this out of the way. It's kind of like your regular calculator where you have different symbols to put different things in. Yeah, I don't see a symbol where I can plug in. Let's go to the functions here and see if there's some sort of function I can do for roots or symbols. See that right there? So I'm going to plugged it in the wrong spot. I'm going to come in here, I'm going to go to functions, scroll all the way down to the bottom, hit this. Now I put my 3 in, and then I put the rest of this stuff in. So I'm going to say x minus 1 divided by, well, it's going to be 2. I got to do this. All right. And then lastly, what I want to do is I want to do y equals x. And I'm going to change this to, let's change this to a dotted line. Okay? Now immediately, what are the things that we notice? Well, they cross both the f and f. Well, it is a function. Okay? Does anybody remember how you could tell if something is a function? What about a vertical line test? Do you guys remember the vertical line test? So what's the vertical line test? The vertical line test is if I take a vertical line and I draw it, okay, and it only crosses that graph one time. In other words, imagine this. I gotta insert a slider. It's not letting me. Well, let's do it this way. Let me take a screenshot of this. And we'll put this in the notes because we need to sketch this. So here are our graphs, okay? So let's label these real quick and then we'll unpack what it means. So this one here is f of x, which is equal to 2x to the third power plus 1. Yeah. And then this one right here is y equals x. Okay. And then this one right here, this one right here is this equation. But before we determine if that equation is a function or not, what we need to do is a vertical line test. So the vertical line test is simple. Let's start with the red line. We know the red line is a function. The vertical line test means that if I draw a straight line and it intersects once, it's a function. So let me move my face. So remember that and write this down in your notes. Vertical line test if it crosses more than one time, okay, so if it crosses more than one time, it is not a function. So right here it crosses one time. If I were to draw another vertical line there, it crosses one time. No matter where I am on this green line, it only crosses one time, right? Do you see that? So this is a function. So what does that mean? Well, that means that because it only crosses one time, I can now do that step 4 and label that as a function. Now let me give you a scenario where it's not a function. So over here, if I graph something in the xy plane like this, and let's make it a different color. I want a purple. Purple will work. Sometimes I can have, and we did this yesterday, we had an equation that when we graphed it, it was like this, right? Well, if I draw a vertical line here, notice that it crosses more than once. So this is not a function. So that's what that vertical line test means. So if we're trying to determine if this equation is a function or not, the last thing we need to do after we graph it is just kind of visually imagine a vertical line going through it. If it crosses more than once, like some sort of scenario like this, then it's not a function and you just leave it as y equals, it's still the inverse, but you just leave it as y equals blah, 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 whatever it is. But if it's a function, which this one is, then we got to do that last step, which is step number 4, right? And then we replace the y with f inverse of x is equal to the square root, or not square root, now I'm talking like you guys, the cube root of x minus 1 divided by 2. Okay? And then I'm going to label this 2 so we know that this is f inverse of x. Okay? Are there any questions? So I'm going to leave this up there for a minute so you guys can finish writing everything down. I think the thing that's important